Today we're learning about mixtures, solutions and suspensions.
Yay! We are aiming to answer the question, what happens when solids and liquids are mixed and why? Can these processes be reversed?
But wait, I need to know a few things first.
Okay, what can I help you with?
What is a mixture?
A mixture? Well, this is what a mixture is. Anytime two or more substances with different properties are dispersed fairly and uniformly throughout one another, they constitute a mixture. The mass of the mixture is equal to the sum of the masses of the component parts.
Okay, what is a solution?
Well, if a mixture is made of a liquid or other solvent and a second substance that dissolves, which disperses uniformly and freely in the liquid, the resulting mixture is a solution. Solutions must be transparent, remember?
Okay, and what about a suspension?
Well, if a mixture is made of a liquid or another solvent and a second substance that does not dissolve in the liquid, the resulting mixture is a suspension. A suspension is cloudy, usually settles out to give a sediment, and can be separated by filtering. Got it?
I think I get it now.
Excellent. Now let's see this in practice. I wonder what happens when we mix a solid, like salt, to a liquid, like water.
Wow, it's disappeared.
Although this is a common child misconception, the salt actually has not disappeared into the water. But you can taste it to try and find out.
Ugh, yuck.
See, it's still salty. However, another more scientific way to prove to children that the salt has not disappeared would be to weigh both parts of the mixture before mixing them together. So if you weigh the salt and then you weigh the water, after you've mixed them together, the total weight should be the same, proving that the salt is still there. Got it?
Get it.
Good.
Yay!
How do you think we can get the salt back out of the water?
I don't think we can get it back out.
Well, we can get it back out, but it's a little bit harder. Since the salt and water formed a solution instead of a suspension, we need to boil the water or wait for the water to evaporate in order to get the salt from the water. Now we are going to mix another solid, in this case rice, into a liquid. We will use water again. What do you notice about our new mixture?
Well, it has two parts.
So what do you think that means? Is it a solution?
No, it must be a suspension.
Exactly!
Yay! So, do you think that we can do the same as what we did with the salt and the water to separate the particles?
I don't think we need to,
No, why is that?
because the particles of the rice are a lot bigger than they were before, and they haven't disappeared or dissolved, which means that we can get them out just by filtering.
That's right.
From our mixtures experiment, can you come up with a claim to our focus question? What happens when solids and liquids are mixed, and why? Can these processes be reversed?
I think as a claim, when solids and liquids are mixed, they can form a homogeneous mixture, or a solution, or a heterogeneous mixture, also known as a suspension. A suspension could be reversed by using filtration, and a solution could be reversed by processes such as evaporation.
That's really good. Well done.
I've learned a lot.
Very good, but do you have evidence to back up this claim?
Yes. In our experiment using water and rice, the mixture could be separated by filtration. The rice did not dissolve. In our experiment involving salt and water, the result looked like the salt had disappeared in the water, but we know it did not. It could not be separated by filtration.
That is very good, well done. But can you put this into reasoning why?
From our research, we learned that a solution is a mixture where the solvent dissolves in the solute, and a suspension is a mixture where the two substances do not form a homogeneous mixture. I have seen that this is correct through various experiments with rice and water and salt and water.
Very good. I'm glad you learned so much.
Me too.
Yay!